Yeah. So today we completed all our electrostats part, isn't it? Now, potential and everything with the help of every such kind of a knowledge and some kind of a, knowledge of the Gauss law, we are going to start the concept of conductors and capacitors, where we will include the understanding of infinite seat and all. Okay, and electrostatic pressure and all. Okay, so I don't treat electrostats and electrostatic potential as two different chapters. I start considering them electrostats, electrostatic potential, and capacitance as one go chapter. Okay, so the first topic which we are going to do today starts with conductors, and then we will understand what is the use of them basically in terms of capacitors and infinite states. Okay. So define what is conductors. Basically, materials have more number of free electrons, isn't it? Which have more number. Insulators have also free electrons. Remember that. Yeah. So those kind of objects which have large number of free electrons, we call them conductors, isn't it? And the question arises that okay, conductors are very good. Electric, they behave. So you put them, if you just put them in an electric field, something will happen. So we are going to study the properties of conductors. What happens to them when we put them in electrostatic conditions? Are you able to get me or not? So let us start. So give the heading: properties of conductors in the electrostatic condition. Is that clear? Okay. So first property, first thing, when you have the conductors, याद रखो, as you know that the net charges appears on the surface of the conductor. So this is why net electric field inside the conductor is always zero. Whether it is solid or hollow, is always how much it is? Zero. Are you able to get me or not? So let's suppose if I take any kind of arbitrarily shaped conductor, okay, then whenever, let's suppose if I select any kind of a point over here, then at all these points, different points everywhere, my net electric field is always how much? Equal to zero. Is that clear or not? But if I have the arbitrary shaped conductor, wait one minute, sorry, and in it, let's suppose some kind of a cavity is made, then definitely over here in this region, the electric field is basically how much? Equal to zero. But inside this cavity, depends, electric field may or may not be zero. Means it depends whether you are putting the charge in the cavity or not. Is that clear? It depends. Means inside the conductor, if it is hollow, then it depends upon some situations where the electric field will be zero and some situations where the electric field will not be equal to zero. Are you able to get me? We'll talk about that. We will talk about that. But definitely, if it is a solid object, Then for the solid object, as you know, the charges starts to appear on the surface. So this is why the net electric field is always how much? Zero. 1 minute. Okay. Is it clear now? So for solids, as the charges appears on the surface, that is why the electric field inside the conductor is zero. But here also the charges will appear on the surface. But over here, we don't know what kind of cavity it is. So that's why it may be zero or may not be zero. Are you able to get me? Is that clear? Second point. Now, since electric field is zero, that means that the potential of every point of the conductor is always same. क्या बोला कि अगर जैसे मतलब मैंने अपन जैसे मतलब अगर ये कंडक्टिंग बॉडी है ना, तो let us select some points. Let's suppose this is point A, this is point B, this is point C, okay, and let's suppose this is point D, and one point I'm considering in cavity which is point E. Are you able to get me? Okay, then definitely the potential on every point of the conductor it is saying. That means that potential at A will be equal to potential at B is equal to potential at D. But E is not the point on the conductor now. So potential at E may or may not be same. May not be same. Why not? So it depends. It depends. It does not says that it cannot be same. Huh. Is that clear? Okay. Can we move to next point? Okay. Let us move on to next point. Third point is now we are approaching to that point when that electric field will be zero, when that electric field will not be zero. But let us first define something, and that thing is that electric field originate or terminate on the surface of on the surface of conductor. The point is our electric field will definitely originate or terminate on the surface of conductor, but in which way? In perpendicular way. This sign means perpendicular. Okay, in perpendicular way. Are you able to get me? Is that clear? So that means what? The concept is simple that electric field lines is background noise is there or what? I'll close my mind. I'll I think now it is fine, isn't it? So after some time I'll open my window. Okay, so now electric field lines, what it is saying that electric field lines will originate or terminate on the surface of conductor. In what way? Perpendicular. Are you able to get me? So that means that if I have electric field lines, so electric field lines and can we say that and the surface of conductor are perpendicular to each other. Is that clear? Are you able to get me? So look over here. Let's suppose if I just select any kind of arbitrary shape conductor, right or not? So that means that let's suppose if here negative charges are there and here positive charges are there, then the electric field lines will, for the positive charges, it will emerge out of the surface in a perpendicular way, while electric field lines will terminate on the surface in the perpendicular way for the negative charges. Is that clear? If I select some kind of a symmetrical object like a spherical kind of object, then for this what will happen? You will see that look over here. Means let's suppose if I consider any kind of a charge, then what you will see? You will see that the whole electric field is terminating in what way? Perpendicular way, or it is originating. If it is a negative charged body, then it will be like how I'll draw the perpendicular. I'll draw the perpendicular in this way or what? Isn't it? It will be kind of a converging towards the center, isn't it? Uh, because normals are always perpendicular towards the center. Is that clear? So you'll see that they are converging towards the center. Why not? So that means they are basically perpendicular with on the surface. So this shows that yes, they are perpendicular on the surface. Are you able to get me? And if the surface is negatively charged, this thing appears whenever we have any kind of a conductor. Are you able to get me? Okay. Next point, fourth point, for property of the conductor, that net charge, whenever we consider some kind of a charge on a system, then there is some property definitely that gets uh, like you can say that emerged with our conductor. So that is, it is saying that net charge on conductor lies always on its surface. Where my net charge of the conductor is always present, it is always present on its surface. Means now the question arises that there are two kinds of surfaces, in isn't it? So basically, it will be definitely present on inner surface also and outer surface also. Is that clear? So let's take an example. If I have arbitrary shaped conductor, and in this conductor, if I have some kind of a cavity, got it? Then definitely, first thing is net charge is present on these outer surfaces. ठीक है. And second thing is this net charge is also present on this inner surface, which is present on the cavity. Is that clear? So net charge is present. Yeah. Is that clear? So it does not mean that I'll have no net charge on my inner surface. I'll definitely have some inner charge on the some charge on the inner surface also. Is that clear? Electric field may or may not be zero. Are you able to get me? Is that clear? Fifth point. Now, whenever I consider a conductor, what happens actually? That I need to define the electric field to the conductor or not. Now, I told you that that conductor is an open surface area, isn't it? So, when I consider an open surface area, what actually happens? You see that. So, net electric field due to, or you can say net electric field on the surface of conductor is equal to always sigma by epsilon naught n cap. I'll make you understand what is the meaning of this. Where first let me write where n cap represents normal unit vector, okay, perpendicular to surface. Are you able to get me? And sigma is the charge density of conductor. Yeah, surface charge density you can say. Are you able to get me? So point is very simple. If I have any kind of arbitrary say conductor, then it is an open surface area, isn't it? So I have to always consider only one area, only one direction of normal. Are you able to get me? So let's suppose if I consider point like here as B, or if I consider point here as A, so then over here the electric field will be perpendicular to it or not. And whatever is the electric field, that electric field, 1 minute, whatever is this electric field, that depends upon what? It depends upon how much sigma is present at this point. So sigma A divided by epsilon naught into n cap. Are you able to get me? If it is here outside, then other side it should be negative. If it is a neutral body, isn't it? So ऐसा भी मान सकते हैं कि here it is going inside, here it is point A, here it is point B. So here the electric field at B will be sigma B by A into n cap. So for any point of the conductor, the electric field is always sigma by epsilon naught. But it is in which direction? Normal direction. Is that clear? Hmm. Is that clear? Now you can ask me, sir, how you are getting this, isn't it? Mm-hmm. So look over here. See that. So how we are getting? Let us write the statement for that. The statement is electric field line or electric field at any point, okay, on a surface of conductor is half due to a small sur a small you can say a small aerial element and half due to, and at that point half due to रिमेनिंग कंडक्टर. अब तुम्हें ये समझ में नहीं आएगा कि सर ने क्या बोला. So let us understand through diagram what it is. It's a very important statement. Okay. The point is that अगर मैंने कोई कंडक्टर कंसिडर किया है ना, तो हम देखो हम कंफ्यूज क्यों होते हैं कि हमें जब हमें वो पढ़ा जाता है इनफाइनाइट सीट पढ़ा जाता है. देन फॉर इनफाइनाइट सीट इलेक्ट्रिक फील्ड इज गिवन एज सिग्मा बाय 2 एप्सिलॉन नॉट. But actually for conductor it is sigma by epsilon naught. But infinite seed is also an example of a conductor or not? Yes, that's right. So point is that you can't calculate the electric field of a conductor without considering the small elementary area. Because if I do not consider the small elementary area, then what will happen is that we do not know the total shape and size of the body. So there cannot be any kind of a Gaussian surface, and we can't define in terms of sigma then, isn't it? So first we define what elementary. Yes, yes. See, do we know that? Do we know the? Do we know the particular? You can say. Can you tell me that what is the total shape and size of the conductor? It's a random conductor. So you do not know. So how to find the electric field? First, I will find the electric field due to the small area, and then I will add it for the all total surface or not. Yes, I'm doing integration, but here integration is not there because for a conductor, since the potential is same at all points, the electric field must be same at all points or not, and that should be given as sigma by epsilon naught. So how that sigma by epsilon naught actually appears by even considering dA element, we are trying to find out that. Is that clear or not? ठीक है, तो इस dA element के वजह से means due to this dA element only the electric field is present, and that is, let's suppose if it is, yeah, I'll call this as electric field 1, word or not. And then we consider that the next electric field is present due to the whole surface area. Are you able to get me? So at any point, if I'm considering to find the electric field, there are two electric fields. One is due to this small elementary element and another due to the whole surface, which we are adding together to get the net electric field. Are you able to get me? So we will write E1 is that electric field due to the dA element, and E2 is the electric field due to the rest of object. I'll draw. So E2 will be in same direction only, isn't it? Due to the whole other reason. This is my E2. So net E is what? E net is given as E1 plus E2. Are you able to get me? And both of them, E1 and E2, are basically nothing but they are equal to sigma by 2 epsilon naught and sigma by 2 epsilon naught. Are you able to get me? So that is how we get the net electric field as sigma. It's a derivation, Balak. It's a derivation which is we will do in the terms of infinite C. Basically, you have to learn it. Otherwise, it's a whole lot of a derivation which does not is present, which is not present at this age. Are you able to get me? You can say that. Means if you want the derivation, I can do, but it will take at least 15 minutes of our time. But it is not for your syllabus. It's not required actually. You have to just learn it. Are you able to? Yeah, you just memorize it as a form. Is that clear? Are you able to get me? So there are two parts. First thing is dA element, and then there is this whole remaining element. The point was to distribute this because I wanted to know the electric field, and I wanted the electric field for this whole object. So that's why we define, even if we consider a small element, the electric field is constant, which is sigma by 2 epsilon naught, and even if we consider the rest of the element, it is sigma by 2 epsilon naught, and that is why the net electric field is sigma by epsilon naught, which is also a constant. Are you able to get me? Yeah, so this was the way to define the electric for these small areas and adding them together. Are you able to get me? Is that clear? Yeah. Now, next point. So, three, this was four, five, this was six. Now, let us consider the seventh point. Okay, okay, wait, I'll open my window because now it is. Okay, so can we move ahead? Now, seventh point is defined as electrostatic pressure. It's an important term. Okay, let us understand. Okay, so what is electrostatic pressure? First, we need to understand that. Now, you look over here. If I have an arbitrary shaped कोई भी एक ऐसा conductor and I charge it and I do what? So, what is actually happening? तुम ही खुद बताओ. These charges will repel each other or not? Yes, they are repelling each other, and due to that, a tension is developed per unit surface area or not? Tension in the body automatically it will develop, isn't it? So due to that, the whole surface of the body starts to feel. Basically, look over here. Due to this, what will happen? Due to this, the body will feel. Let's suppose if I consider a small elementary area, this elementary area will start feeling some force due to the repulsion or not. Yes, and you can say that, sir, how is this DF like this way? So basically, if I have any kind of a curvical object, so look over here. This side I'll have some tension, and this side I'll have some tension, which will make some angle theta with the horizontal or not. Yes. So basically, what I will have, I'll have 2t, some small tensions. I'm considering dt and dt. So dt cos theta, dt sin theta, and dt sin theta along this downward direction are able to get me. Now, these thetas are very small. So net tension developed is in towards the center of the body, which is dt. And since it is a repulsive one, I'll consider it outside. Are you able to get me? Got it? So this is why every point is feeling some kind of a force which is present in the outside. Yeah. So let us consider that area of the element is dA. Okay. So dF is force present, and dA is the elementary area. Then the electrostatic pressure. First, let us write the statement. What is electrostatic pressure? So electrostatic force per unit area on one small part of charged object due to remaining part, okay, of the object is known as electrostatic pressure. Is known as so that is generated due to the repulsive force, isn't it? Yeah. Are you able to get me? So let's suppose if the charge density of the object is sigma, then we can write now that this force This force means there is some force present on the body. So force will be what? It will be on this small area. So it will have this small area will have a small charge, isn't it? उसको बोलो हाँ है ना? So this dF will be equal to dq into, since the electric field is always constant on the surface of this body. So electric field dF is equal to dq into A. Electric field. Okay. So dq is what? Dq is nothing but charge into surface area, isn't it? Sigma is equal to a small charge by a small surface area into electric field E, which is sigma by 2 epsilon naught. Now, you see, that's why I told you earlier that why I'm defining that electric field due to the rest of object. See, on this object, I can't consider the electric field now because that is originally present. But the net force is applied by all those charges which are present on the rest of the conductor, isn't it? So this is why this electric field is due to the force is generated by the rest of the conductors. That means the electric field should also be for the rest of conductor. Is that clear? Yeah, yeah. Now that means I can write dF by dA as sigma square by 2 epsilon naught. But what is dF by dA? It is called as pressure, isn't it? So therefore, electrostatic pressure, इसीलिए जब जब तुम बैलून लो, take a balloon and charge that balloon, charge a conducting balloon, ठीक, then what will happen? That balloon will start inflating because electrostatic pressure is generated, which is equal to sigma square by 2 epsilon. Is that clear? So there is a difference between the electric field due to the whole of a conductor, which is sigma by epsilon naught, and electric field due to the small area and electric field due to the rest of the area. Is that, isn't it? So this is why we need to define dF is the, I can say you will write dF is force present on force present on elementary dA due to the rest of object. Is that clear? Sure. ना अब देखो ध्यान से, फोर्स आ गया बॉडी के पास, बॉडी रेस्ट में है, तो इसका मतलब बॉडी के अंदर एनर्जी स्टोर होगी ना, और इस एनर्जी को बोला जाता है इन फिजिक्स, इट इज कॉल्ड एज सेल्फ एनर्जी और सेल्फ पोटेंशियल एनर्जी, which is very very important for us to understand. So 8th point, self let me write self potential energy or self energy. Is that clear? ये आगे जाके बहुत काम आने वाला है ना? So it is nothing but it is defined as, let us define the statement. It is electrostatic or electric potential energy, not kinetic energy. You know that why? Because the conductor is at rest. Electric potential energy and the body is static in nature. We are studying electrostats, isn't it? So electrostatic potential energy between the charges of object of the conductor or any material or any system is called as self potential energy or self energy. Are you able to get me? जैसे मान लो अगर मैं एक एग्जांपल लेता हूँ, जैसे तुम कुछ सोचो कि अगर मान लो एक डाइपोल है ना, ये हो गया प्लस क्यू, ये हो गया माइनस क्यू, जिसके बीच की डिस्टेंस है मान लो आर। तो इसके बीच की जो एनर्जी, पोटेंशियल एनर्जी होगा, क्या लिखेंगे? माइनस 1/4 पाई एप्सिलॉन नॉट क्यू स्क्वायर बाई आर स्क्वायर. So this is called as, this whole thing is going to be called as self energy or self potential energy of the system. Are you able to get me? So let us suppose if I define this self potential energy for some objects. So first case, since we studied a sphere, okay. So the first case is self energy of charged sphere. Is that clear? First one is conducting, second one will be non-conducting. Is that clear? So let's suppose if it is a conducting sphere, you know the radius. Let's suppose the radius is r, and this also radius is, yeah, I'll mention it. Don't take attention. This is conducting sphere, solid. तो अच्छे से, this is solid conducting, and this is solid non-conducting. Okay. Then बताओ क्या होना चाहिए? एटलीस्ट कंडक्टिंग का बताओ पोटेंशियल एनर्जी क्या होना चाहिए? तो ध्यान से देखो, इसकी जो पोटेंशियल एनर्जी होती है वो होती है, इफ मान लो चार्ज क्यू, के क्यू स्क्वायर डिवाइडेड बाय 2r. आर नहीं होता है, 2r होता है. इज दैट क्लियर? हाँ. सो इफ इट इज हॉलो और सॉलिड, दोनों का बात बराबर है, हमें मालूम है. I found out this potentially. Think of that why it is kq square by 2r. Got it? Is that clear? For solid non-conducting, it is u is equal to 3kq square by 5r. Is that clear? If the charge q is there, 5, yes, 3kq square by 5. Are you able to get me? ये फॉर्मूला है, बस स्फीयर का याद रखना है. स्फीयर के अलावा और कुछ तुम्हें सेल्फ एनर्जी याद नहीं रखनी है, ठीक है? You don't have to remember other self energies. You have to just remember for the case of sphere only. Yeah, because see, if I go on derivating everything, then it will take means you can't say that even it will be completed within 1 year or not. Okay, because electrostats is something which we have to sometimes start learning, and here in the conductors case we have to learn something. Are you able to get me? थोड़ा मारना पड़ेगा, है ना? ठीक है, समझ में आई बात? इज दैट क्लियर? ठीक है. So look over here. 1 minute. Induction in metal. Hmm. So the point is, I can define very different cases. I can define uh, different relations also, but it will be of no use when you go to the higher sections. Is that clear? So this is why I'm not defining every case. I'm just trying to find some of the cases, and I'll show you how to do it. Are you able to get me? Now look over here. So the question arises that when I have a non-conducting sphere, so 3 kq square by 5r is for which point? That is the biggest question, isn't it? So this 3 kq square by 5r is for the total body. Is that clear? It is for which body? Total body. Are you able to get me or not? Are you able to get me? So if you want the derivation, I can do. What do you want? Should I do the derivation or should I leave it? Yeah, it's really you will have to understand the work energy form. Okay. We will do okay. So we will keep in conserve because we have capacitors and current to still complete because your exams are approaching, isn't it? So we will do at the end if there will be enough time left. Okay. So I'm just giving this homework as derivation. Okay. Is that clear? And then you try it. Achha, another thing is like in second term, see when we are defining potential energy between the charges of the conductor or any material or any system, that is my self potential energy. But the question arises that what is in reality this is. So look over here, how this potential energy is created. We bring this charge from the infinity, then this potential energy is generated or not. So the self energy is nothing but the energy which is stored during the work done to bring the charge from infinity. Remember that. Is that clear? Are you able to get me? So that is how the self energy is generated. Okay. चलो आगे बढ़ा जाए. Oh sorry. Okay. Now look over here. So अब क्वेश्चन आता है कि सर ओके ठीक है चलो सेल्फ एनर्जी हो गया सब कुछ हो गया तो इसका मतलब जो एनर्जी है सिंस इट इज यू लुक ओवर हियर आई हैव सम वॉल्यूम ऑफ द कंडक्टर और नॉट then this volume of conductor will have some electric field, isn't it? Some field lines at some region. Then it means you can say that for any kind of a conductor, these electric field lines are what? They are basically arranged. They are basically present. Okay. And based upon the amount of strength of these electric field lines present in some kind of a volume, we can define the electric field or not. So this is why it is necessary to define electric field density with respect to volume. Are you able to get me? So look over here. So you have to basically remember this formula. So we call it as energy density. Energy density of electric field. Is that clear? It is given as energy per unit volume. You see that our potential energy, self energy is getting distributed, isn't it? So this is energy per unit volume. It is given as 1 by 2 epsilon naught, sorry, ES square. So energy per unit volume in the electric field is 1 by epsilon naught, 1 by 2 epsilon naught ES square. Are you able to get me? Is that clear? And this is why the amount of energy which will be stored in the electric field, which I told you right now, energy is stored in the electric field is provided by equation integral half of epsilon naught E square dV, where dV is volume element of the body. And if electric field is uniform, so just remember this formula. They are of not typically big use. Okay, just formulas are there. Are able to get me? There is no such numerical which will come out of this. It comes usually in Z once. So we will discuss later on when we'll have time regarding that. Is that clear? So if electric field is uniform, the particular energy per unit volume is given as, or energy is stored in the electric field stored STOR, it is stored in electric field is half epsilon naught T square into volume of the object. Is that clear? Are you able to get me? So this was about the point of like how the conductors creates their own pressure, creates their own energy, and how the energy is stored. The main task of this will be utilized in EM waves when we will have the discussion of speed of light, and that is when it is going to be requirement. Are you able to get me? Yeah. Before that, it's of no use. So can we move ahead? Now, the last point of conductors, which is very important for us to understand, is the sharing of charges through the conductor. Okay. Now look over here. अब ध्यान से सोचो. What happens when two conductors are connected? Something will happen. Okay. So let us see. When two conductors are connected, when two conductors are connected with each other, what happens? Their potential will become same or not? Each other by any kind of a physical contact or by conducting wire. Then charge flow starts to take place. Is that clear? क्या होता है इसके वजह से चार्ज फ्लो बढ़ने लगता है, isn't it? Now when the charge flow will start, the question arises that till what time this charge flow will be happening. So till their potential becomes equal. So this charge flow will happen till the time or till the point where the potential becomes equal to each other. Are you able to get me or not? So this is the sharing of charges. First case when we connect them physically by with the help of conducting wire, or two conductors are connected. But I can also have a conductor connected with the ground, isn't it? So second kind of sharing of charges happen when conductors are connected with earthing basically. And this is what is the second chapter of Gauss law has, which we call it as grounding. Okay, earthing. Then what will happen? So then once again the charge flow will happen. So when the conductors are connected with earth, then charge flow take place till the potential of conductor becomes zero. Till what time the charge flow will happen? Till the time when the potential of conductor becomes equal to how much? Zero. Are you able to get me? Yes. So this is basically the reason for this is the potential of earth is how much? Zero. Is that clear? The reason is, yeah, no, no. Potential of earth is zero. Now you see that potential of earth will be written as kq by r or not. So charge present on the earth is very very small, while r is very large, isn't it? So this is why potential of earth is zero, and this is why the potential of conductor also becomes equal to zero when it is connected with the earth. Is that clear? Try to become zero. Yes. Yes. Yeah. Are you able to get me? Mention it and then we'll move ahead. Okay. Done. Okay. So these were all the properties of conductors which we had understood right now. Now we are going to utilize this to understand, to do some numericals. Like we will do some numericals based on this, and we will try to find the energy and all of the things kind of questions. Is that clear? Okay, so let us do the first question. It says that, let's suppose I have two concentric cells. Is that clear? So I have two concentric spherical cell. ठीक है, वो छोटा करते हैं. Are you able to get me? The radius of each cell is given. Inside one it is R1, outside one it is R2. Are you able to get me? Next thing is, if outer one is charged with charge Q2 and inside one is charged with charge Q1, then question is, बोल रहा है find the total potential energy, which is also called as self energy, of the system of two concentric of the system, and also the work done or work done to double each radius. बताओ. Mhm. बताओ जल्दी क्या होगा इसका आंसर। आसान क्वेश्चन, इट्स टू इजी। अच्छा एक बात बताओ, अगर सिंगल सिंगल चार्ज है तो उनका एक खुद का एक एनर्जी है या नहीं, विच इज कॉल्ड एज सेल्फ एनर्जी। यस, एंड सो लुक सीधा, if I write total potential energy, so then total potential energy here there are two. First one is interaction due to Q1 and Q2, and second thing is self. Now you got the idea why I taught you the self potential energy of the sphere. Hmm. Interaction due to Q1 and Q2, तो ध्यान से देखो कैसे निकालेंगे। मान लेते हैं कि जैसे हम Q1 की वजह से Q2 के ऊपर निकालेंगे। Is that clear? So let us suppose this is cell 2 and this is cell 1. So I consider a very small charge. Okay. If I can find the potential on this very small charge, I can find on the whole cell or not. So I call it as dq2. क्या बोल रहा हूँ मैं इसको? dq2. So look over here. Let us take a small charge. Then I'll later on I'll tell you the trick. But right now you understand the full way. A small element dq2 on cell 2. Is that clear? And so look over here. So basically due to the cell 1, the small potential will be there or not. So potential, this implies that potential on the small element dq2, okay, due to cell 1 is how much? क्या होगा bro साहब? कैसे निकालेंगे पोटेंशियल एनर्जी? पोटेंशियल एनर्जी लिख लो, पोटेंशियल नहीं सिर्फ पोटेंशियल एनर्जी। 1 मिनट। इज दैट क्लियर? तो पोटेंशियल एनर्जी का फॉर्मूला क्या होगा? du, स्मॉल चार्ज निकाल, स्मॉल पोटेंशियल एनर्जी एग्जिस्ट करेगा ना, इट विल बी du into the charge dq2 and due to and the potential on cell 2 by cell 1। यही होगा ना फॉर्मूला? पोटेंशियल एनर्जी का यही होता है ना। पोटेंशियल एनर्जी इज व्हाट, हमने क्या बताया था? पोटेंशियल इज इक्वल टू पोटेंशियल एनर्जी बाय चार्ज। तो अपन यूज कर सकते हैं ना पोटेंशियल एनर्जी इक्वल टू पोटेंशियल इनटू चार्ज। यस। सो du बराबर क्या आएगा? dq2 पोटेंशियल ऑन 2 ड्यू टू 1 क्या है? पोटेंशियल 1 पे चार्ज है q1, तो k q1 बाई रेडियस कितना है? डिस्टेंस r2 कांस्टेंट है विच इज r2। तो नेट पोटेंशियल एनर्जी क्या आ जाएगा? सिंपली if I can integrate it, then I can get the net potential energy or not. So net potential energy means you can say that this is the interaction potential energy, which is equal to सिंपल, अगर dq2 का इंटीग्रेट करेंगे तो q2 हो जाएगा। तो इक्वेशन आया k q1 q2 बाय हाउ मच? r2। क्या मेरी बात तुम्हें समझ में आई? इज दैट क्लियर? बस। तो ये तुम्हारा क्या क्या लाया? इंटरैक्शन पोटेंशियल एनर्जी। ठीक है, वेयर r2 इज द आउटर रेडियस। इज दैट क्लियर? समझ में आया? अगर तुम लेट सपोज इफ यू इवन took the particular small element on the inner surface, then you would be required, अगर मान लो देखो जैसे अगर मान लो इनर सरफेस पे ले लेता dq1 है ना, तो पोटेंशियल का फॉर्मूला क्या आता है? सिंपल, du will be dq1 but potential on 1 due to 2 or not। Yeah, so this is the equation Means you can say this is the equation if we take element of, yeah, no problem, element of cell 1. But you see that, you see one of the most important thing that when you do this du बराबर, बताओ dq1 इंटीग्रेट कर सकते हैं dq1 एंड v12 क्या होगा? तो हम इनर साइड पे जा रहे हैं ना, इनर रेडियस पे कहाँ पर, r1 पर, हम r1, लेकिन हमें मालूम है कि if it is a spherical cell inside that the electric field is zero, isn't it? So potential remains constant or not, which will be exactly equal to k q2 by r2. r1 कैसे, r2 only ना? अरे बाबा, look over here. If it is a sphere of radius r2 and I want to find the potential over here, and here my charge is q, so this potential is still same kq by r2, because this distance does not matter, the potential remains the same. Electric field is zero, isn't it? Is that clear? समझ में आया? तो इसका मतलब क्या कि अगर मैं बाहर वाला कंसिडर करूंगा तो मैं इनर स्फीयर को एकदम नेग्लेक्ट ही मार दूंगा, मालूम, मेरे को मालूम ही नहीं कि इनर स्फीयर एग्जिस्ट भी करता है। अब तुम पूछोगे कि सर ऐसा क्यों? नहीं नहीं, मतलब तुम ऐसा पूछ सकते हो कि सर ऐसा क्यों, है ना? तो बालक ध्यान से देखो, इनर स्फीयर इसलिए नहीं माना जाता क्योंकि जब हम बाहर का सरफेस कंसिडर किए, इस पे चार्ज Q2 है, तो ध्यान से देखना, मजा आएगा। ये चार्ज Q1 है ना, तो Q1 की वजह से यहाँ पे इंड्यूस चार्ज माइनस Q1 आएगा या नहीं आएगा, और यहाँ पे कितना आएगा, प्लस Q1। आर एबल टू गेट मी? तो ध्यान से देखा जाए तो ये माइनस Q1 और प्लस Q1 मिलके एक दूसरे को कैंसिल करेंगे या नहीं करेंगे, टोटल जब हम कंसिडर करेंगे। So that is why we do not consider the inner sphere. Is that clear? Are you able to get me? And that is why it is kq2 by r2. So this is why net potential is still same, potential interaction, which is k q1 q2 by r2. Is that clear? So we can find the first answer, that what is my total potential energy. So total potential energy is first interaction, which is k q1 q2 by r2, plus interaction self energy of first sphere, which is k q1 square by twice r2, self energy of second sphere, which is k q2 square by, oh sorry, twice r1 यहाँ पे होगा, r1, and this is twice r. Is that clear? Are you able to get me? Next thing it is saying that find the work done to double the radius. अब इतना आसान problem है. Work done is what? What is that? Since it is an electrostatic force, it is just negative of change in potential energy. Yeah, isn't it? So work done will be what? U, yeah, U initial minus U final. Electrostatic is a conservative force. That's why I can apply this formula. So work done is equal to, U initially. U initial is how much? Initially my radius was R. So potential energy initially was K Q1 Q2 by R2 plus K Q1 square by twice R1 plus K Q2 by twice R2। या ये U इनिशियल है, मैं डायरेक्टली ऐसे लिख देगा। अब माइनस ऑफ U फाइनल जो है वो ट्वाइस रेडियस है ना। आर यू एबल टू गेट मी? अरे बाबा, change in potential energy is what? U final minus U initial. If you put minus over there, so just do not, just consider initial minus final. That will help you. Okay. So then it is K q1 q2 radius r2 double, so twice r2 plus the terms k q1 by 4r1, isn't it? 2 to the 4, isn't it? Plus k q1 q2 is square by 4r. So this is your whole term. Subtract it and you will get the answer. Is that clear? Are you able to get me? So this is my net work done. Are you able to get me? Chalo. So should we do next question? Okay. Question number 2. Try to solve it, yeah, and give me the answer tomorrow. Okay. Okay. Once again, I have spherical cells. Yes. So now your whole fear will be over because whatever we are solving is interesting. So I have R1, R2, and R3. There are 3 cells, isn't it? One is having charge Q minus 3Q and plus 5Q. Question is, question is find the charge on each surface of each cell. Is that clear? बताओ जल्दी से. Find the charge on each surface of each cell. Can you try it? Achha, what is the meaning of see? Basically, we know that all conductors do induction, isn't it? So look over here. Inside it, it will be 0, isn't it? But due to plus Q, due to this Q, there will be another charge minus Q developed over here or not. And then plus Q over here. So net charge on the second surface becomes how much? On the top of this, minus 2Q, isn't it? Are you able to get me? Are you able to get me or not? A net charge, red one represents the net charge. Inside it is minus Q, inside surface it is minus Q. This is plus Q, this is 0. Is that clear? Now I'll deal with plus 2Q to the other side, isn't it? Minus 2Q will develop plus 2Q over here on the third inner surface. Is that clear? And here already plus 5Q is there. So minus 2Q will develop or not? So net charge is plus 3Q. Is that clear? And plus 2Q on the inner region. So outer surface of third sphere plus 3Q, inner surface plus 2Q, outer surface minus 2Q, then inner surface minus Q and plus Q and 0. ठीक. Is that clear? तो मतलब तुमने देखा स्टेप वाइज स्टेप करना है, मतलब पहला सरफेस का निकाल दो, फिर दूसरे सरफेस का जब निकालोगे तो find the total charge and then induce it. If you put minus 3q on this down surface and plus 3q on this down surface, then it is of no use. It's an incorrect answer because you didn't find the total charge. Yeah. So there are steps to do it. So I'm writing those steps. That is very, very necessary. That first charge, remember that charge on the inner surface is equal and opposite of net charge inside. Canicla, conclusion, that charge on the inner surface is always equal and opposite of net charge inside. Are you able to get me? ठीक है. Second point. Now, how to use the charge on cell? So use charge on cell as, or it will be equal to, first thing, charge on the inner surface two surfaces everyone can solve, but three surfaces they will get confused. Why? Because they will not do the equal partition, right or not? So you remember, you have to always go with one by one. Charge on outer surface. Is that clear? समझ में आया? Let us do one more problem. Now we are entering into a three set problem, which is very, very important. Okay, this is three set problem, but we'll do step by step. Yeah. Question is, let's suppose initially on this surface the charge was Q2, and in this surface the charge was Q1. This is radius R1, this is radius R2. Is that clear? बोल रहा है कि if there is a switch which is located between the two surfaces, is that clear? Question is, find the charges on a sphere. In all cases, find the charges on a sphere when the switch is closed. On each cell you should write. On each cell when the switch is closed. Is that clear? Do it. What will be your answer? In Mhm. Where do the 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 switch is closed, then there will be induction. Switch is closed, or before switch is closed also there will be an induction. After switch is closed there will be charge distribution, not induction. Okay. Before switch is closed only there is an induction minus Q1, and then here it will be plus Q2. Is that clear? So the top surface has a charge Q2 plus Q1, and it has the inside surface has charge Q1 only. Got it? And after switch is closed, when the switch is getting closed, simple the induction process will start. When the switch gets closed, sorry, when the switch is getting closed, the charge distribution will start. It means that it's not induction. The charge distribution right now we understood that when you connect the conductors with wire, then they share the charge. Charge flow is there till the potential becomes equal. So they are conductors basically, spherical cells. Now, if I connect the switch is closed, that means they are connected by wires in between them, isn't it? So they will share the charge till their potential becomes how much? Zero. Equal. Till their potential becomes how much? Equal. Are you able to get me? So let's suppose after after switch is closed, the charge on this inner sphere becomes x. How much it has become? X. So then on the this one it will be minus x, uh, or you can say sorry. If charge distribution is taking place, no induction. How I am doing induction. So when the switch is closed, the charge distribution will start. So inner sphere, if it is becoming x, then from q like from the outside one, the net charge should be subtracted or not. Is that clear? So point is simple. Like if I can select point A or point x is the charge. X is the charge on the inner sphere after distribution. Look over there. Which surface has more charge? Inner or outer? Tell me which surface has more charge, inner or outer? Initially Q1 was on the inner surface and Q1 plus Q2 was on the Outer surface. So basically, the some charge from the outer one will come on the inner one, isn't it? Yeah. So let's suppose the some charge. If let's suppose the some charge taken from the outer one is x, then on the inner surface it will become how much? X only. Are you able to get me? Because this Q2, this Q1 will be redistributed, isn't it? Are you able to get me? What? What you are not able to get me? To me. See, first thing, पहला point ये है कि ध्यान से समझो. There are two processes. Before the switch is closed, and after the. So when I consider before, so they are independent bodies. If it has Q1 and it has Q2, so this one has minus Q1 and this one has plus Q1. That is clear. Now, when the switch is closed, they will redistribute their charges till their potential becomes equal, isn't it? So the outer charge was more, isn't it? So what will happen? Some charge will come and it will appear on this surface or not. Now, look over here. When you connect it, when you are connecting it, you are connecting from the inner surface or not. Acha, I think you might be thinking of this. What happens with this Q1, isn't it? So look over here. I have minus Q1 and here has plus Q1. So they will neutralize each other, and then the X charge will only appear on this surface or not. Got it? Is that clear? So you have to see how you are connecting. Is that clear? So when I connect with the inner one, what happen after the switch is closed, outer surface charge sum is taken and given to the inner surface of this, and these two plus Q1 and minus Q1 gets neutralized. Is that clear? So that is why I'm not saying that the after switch is closed, the net charge on the inner one is Q1 plus X. Is that clear? Okay. Yeah. So that will get cancelled or not? You only think. Yeah. So look over here. Then the potential of A must be equal to potential of B. What is potential of A? Tell me. First, due to own charge, K x by R1, and then due to the outer sphere, there will be some potential on it or not. K Q1 plus Q2 minus x divided by क्या लिखेंगे R1 या R2 बताओ. It should be R1 or R2. हाँ हाँ R2. Yes, on the inner one, due to outer surface charge, it is electric field is zero, so it should be R2. है ना? So when I see, look over here. So definitely remember that when you start from center, when we write for the inner surface, then its own potential at R1 and outer potential as it is, we will put it on their surfaces. Go ahead or not. So that is equal to VB. What is VB then? Their own first K R2 plus due to inner one there will be also there K. So this point works like a outer surface for the inner charge or not. So K Q1 by how much? R2. Is that clear? So this is the difference between VA and VB. In one case, R1 and R2 both appears. In another case, R2 and R2 appears. Is that clear? So why negative Q1? Sorry, I wrote Q1. Sorry. Q1 will get cancelled. X. I have to write X. KX by. So you can solve it, isn't it? So equation will be like kx by r1 plus kq1 by r2 plus kq2 by r2 minus kx by r2 is equal to kq1 by r2. Matlab, this term I can, oh sorry, why I'm writing all these terms? I can cancel these terms directly, isn't it? So I'll get kx by r1 is equal to kx by r2. So that means what? Now what you will say? So can I just write it as kx r2 minus r1 equal to 0 or not? So this implies x is equal to how much? 0. मतलब after redistribution, when you close the switch, the net charge on the inner surface becomes equal to how much? 0. This one is 0, and outer it is just q2 plus q1 whole. You only think if the conductor is there, logically also you can say the answer that if a conductor is there, then the net charge will appear on the outer surface. So when you are connecting it, you are basically saying that this is my outer surface, isn't it? So the net charge whole as it will appear on the outer surface, which is q2 plus q1, and the inner surface will become once again neutral. Are you able to get me? Is that clear? Okay. Okay. Second question in the same pattern. Once again, radius is r2 and r1. Let me just increase the second size. R2, R1. Is that clear? But one thing is there, this time the outer surface has a connection with the ground. Switches. If this one has Q1, this one has Q2, initially, then question is once again find the charge on each surface when the switch is closed. Is that clear? Okay. So let us take a half an hour break and then once again we'll meet at 6 p.m. Okay? ठीक है?